Hi, I'm here to talk about acceleration and velocity, what they mean, and some of the really important differences between them, because people often get these mixed up. So, we've mentioned before that these are both vectors. Now, there is a scalar quantity for velocity that's very similar to velocity, that's speed, right? But velocity is a vector, so it has a direction to it. So velocity is a combination of speed and direction of motion of an object. And it's measured in meters per second. So if you're going at 20 meters a second east, that would be your velocity. 20 meters a second would be your speed. Acceleration is the rate of change of velocity. How much is your velocity changing? So let's say you could measure the speed of an object, and you said at time equals 0 seconds, it was going at 0 meters per second. So it's stopped, but it's not going to stay stopped. So after 1 second, it's now going at 2 meters per second. And at time equals 2 seconds, it's going at 4 meters per second. You have to ask yourself, the velocity is increasing. What does that tell you about acceleration? Well, each second, the velocity increases by 2 meters per every second. So each second velocity increases by 2 meters per second. So that means your change in velocity is going to be 2 meters per second each second. So another way to write that is acceleration is 2 meters per second squared. You could put this into the form of an equation where you said acceleration is the change in velocity over time. In this case, change in velocity, delta v, is acceleration per second, right? So I'm just basically rearranging this to say delta v is acceleration times time. I hope that makes sense. So if you know an object is moving east, its velocity is going to be headed east. If an object is moving west, its velocity is going to be west. If it's thrown up in the air, its velocity is pointing up in the air. That's what velocity tells you. Excuse me, sorry about that. Acceleration does not need to be in the same direction as velocity. And in fact, it often isn't in the same direction as velocity. Acceleration is really tied to force. So in order to change the speed of an object, to accelerate an object, you need an unbalanced force. To cause an acceleration. And so for this reason, acceleration is always going to be in the direction of that unbalanced force. We also might call this the net force. So always, acceleration is always in the same direction as your net force. And I'll explain what that means more in depth later. So let's think about this then. If an object is moving east, that means your velocity is to the east. If you want to cause that object to speed up, you've got to push it to the east, right? You've got to push it in the same direction. So in order to speed it up, you've got to push it in the same direction as it's moving. And if you're pushing it to the east, that means your acceleration is also in the same direction to the east. If you want to slow it down, if it's moving east, you want to slow it down, you've got to push it to the west in order to slow it down. Something has got to push it to the west in the opposite direction. So that means that even though its velocity was east, if it was slowing, its net force and its acceleration would be to the west. So if I were to simplify this into a statement, I could say, if acceleration and velocity have the same sign, that's speeding up. Meaning, let's say we define east as positive and west is negative. If they're both moving to the east, they both have the same sign, and the acceleration's to the east also, then it's speeding up. If acceleration and velocity have opposite signs, meaning they're in the same direction, that is slowing down. Now you can also have them in a variety of other directions. For example, with circular motion, in circular motion, the velocity is always going to be tangent to the curve. So let's say you had an object going around like this. Its velocity is going to be tangent to the curve, but its acceleration will be towards the center of the circle. And it's this acceleration that causes the velocity to change. So when I said acceleration is the rate of change of velocity, you can actually have occasions where you can be moving at a constant speed, like in a circle, but it will still be accelerating because the direction of motion is changing. So even if the speed is constant, if the direction of motion is changing, that means you have an acceleration. These terms are going to be confusing for you at first, but as you get more practice, you will definitely get a lot better at this. Just remember, velocity tells you the direction an object is moving in, acceleration tells you how the velocity is changing, and it's always coupled with the net force. So your velocity and your net force, you're pushing, whichever direction you're pushing, are going to be in the same direction. Thank you.